Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about circular linked list and also how to create the circular linked list. So I request everyone to watch the complete video for better understanding. First, let me give an introduction to the circular linked list. Circular linked list is also a linked list. A linked list is a collection of nodes where each node will have the data and address of the next node. Take an example here. We have three nodes which are there in the address location such as 100, 200, 300 respectively. Now you have the data which is 10 and the address of the next node is 200 which is stored here. So this node is pointing to this node. Similarly, this node has the data 20 and address of the next node which is 300. So this node is pointing to this node. If it is a single linked list, simple single linked list, this is the last node. Am I right? This is the first node, this is second node, then this is the third node which is the last node. Now if it is a single linked list, we have the here null because address of the next node, after this node there is no other node, so here you will have the null. Am I right? But however, it is a circular linked list. If it is a circular linked list, it follows the circular principality. So address of the next node at the last node will have the address of the first node. So this is the last node, address of the next node will have the address of the first node. So that's why it is forming the circle. Now we will have two pointers which is as head and tail. The head will consist of the address of the first node and tail will consist of the address of the last node. So I hope you have understood the basic difference between the single linked list and circular single linked list. Now let me discuss how to create the nodes in the circular linked list. What is the structure we have to follow? We have to create a node, okay? So we will use the structure. Why we are using the structure? Because one is the data and another is the address of the next node. So we have heterogeneous data types. One is the integer and another is a pointer which is storing the address. So we need to create a structure. So what is the way to define a structure? We have to write the strut keyword and structure name. What is the structure name here? Node. So that's why I have written here. And what are the members? One is the data which is an integer and another one is a pointer, okay? Now look at here. You can say that, sir, this is a pointer. Okay, what is a pointer? Pointer is a variable which stores the address of another variable. If it is an integer pointer, it stores the address of an integer variable. But this pointer stores the address of what? A node which is of a structure. So that's why for the pointer also we have given the data type as strut node. So this pointer holds the address of a one structure. Now once we define a structure, memory will not be allocated. Once we declare the variables, then only memory will be allocated. So I am declaring two pointers of strut node type. One is head and another one is tail. Initially I am making head and tail is equal to null. So head is equal to null or head is equal to tail is equal to null. If head and tail are null, then you can say that circular linked list is empty. Am I right or wrong? So now let me write the user defined function called create to create the circular linked list. Okay, this function does not return any value, so that's why I have specified the return type as void. Now if you want to create a circular linked list, you need to create the nodes. Okay, so that's why first we are declaring a pointer called new node of type strut node. Then we need to allocate the memory. How we will allocate the memory? Dynamically using the malloc function. So we will write strut node star. It is a typecasting. I will discuss once. Let me complete the entire one, then I will discuss in detail. Size of strut node. Now look at this one. If you want to allocate the memory dynamically, you can use malloc function or cloc function. Here I am using the malloc function. Now malloc function returns a void pointer, but this pointer is a strut node, so that's why we are doing the typecasting. and how much size of memory you want to allocate, that you have to specify here. So I am writing size of, which is an operator, and strut node. So whatever the size is required for this node, that much memory you are asking us to allocate. Now once you allocate the memory, is it clear? Suppose, let's just for an example, you have allocated 8 bytes of memory starting from 100 location to 107 byte. Now this new node pointer will get the base address. If the memory has been successfully allocated, this malloc function will return the base address, which is 100. Are you able to understand? Due to some issues, this malloc function could not able to allocate the memory, then malloc function will return a null value. If new node is having the null, then you can say that address has not allocated, or the memory has not been allocated. Is it clear? It is not address, memory has not been allocated. Is it clear? Just for understanding, let me assume that memory has been successfully allocated. Okay, so then base address will be there in the new node. Now once we have created a node, we need to enter the data. So I will ask the user to enter a value. Printf, enter the value. Once the user has entered the value, we need to read it with the help of scanf function. Scanf %d ampersand new node of data. So whatever the value user is entering in the new node of data, I am storing that value. Suppose let's take that user has entered the value 10, then I am storing here. Is it clear? Are you able to understand? As it is an integer, I have used the format specifier as %d. Okay, then we have to write new node of next is equal to null. Okay, currently we are making it as a null. Okay, are you able to understand? Then we have to check if head is equal to null, meaning is that currently the linked list is empty. If it is so, if linked list is empty, whatever the node we are inserting or whatever the node we are creating, it is the first node. Am I right or wrong? Let me discuss here. Let me erase this one. Let's assume that head is equal to null. Initially we assume that head is will be null, then only we can say that linked list is empty. So head is equal to null, so the condition is true. If it is so, whatever the node we have created, it will be the first node. Am I right or wrong? So we have inserted the value 10 and here we have written null. Are you able to understand? Now head and tail both will be pointing to this node. So what I will write is that head is equal to tail is equal to new node. What is the new node will consist of address of this node. Let's assume that address of this node is 100. Okay, so new node will have the base address which is 100. That you are writing head is equal to new node. So head will consist of 100 and tail also will get the 100. So both are pointing to this node. Then what it should have, as it is a first node, again you have to follow the circular principle. So this node is pointing to itself. Are you able to understand? This is the circular principle. So what you have to write? You have to write tail of next is equal to head. Okay, tail of next is equal to head. What is there in the head? Which is 100. Tail of next, tail is 100, of next is this one. Okay, which is equal to head. So you are getting 100 here. So this node is pointing to itself. Else, if this condition is false, meaning is that you have the some nodes in the linked list. Let's assume that you have currently 2 nodes are there. Okay, just for your understanding. Okay, 100 address, 200 address. You will have head which is having the address is 100 and tail will have the address as 200. Okay, these are the values which is nothing but the address of some node. Are you able to understand? Now else meaning is that head not equal to null. Yes, head is having the value called 100 which is not equal to null. So if you want to insert a node, meaning is that you whatever the node you have created you want to insert, then what you have to do is that what you have to do. So this node you have created, let's assume that you have created this node which is there in the address location 400. So no node pointer, okay, will have the value which is 400. Now here data, let's assume that I have inserted 40 and new node of next is null. Is it clear? Now the user has again called the create function and then he has allocated the memory using the malloc function and he has entered the value as 40 and new node of next is null. Now this one you have to insert here. So how you will do is that tail of next is equal to, because tail is here, 200 of next is 100. You have to assign new node. What is new node is consists of 400 that you are writing here. So then this link will be down and this link will be created. Is it clear? Then what you have to do? You have to move the tail here. So what you will write here is that tail is equal to new node. Now what is new node consists of 400 that you are writing here. So now tail is pointing to this node. Then again you will write tail of next is equal to head. Tail of next, tail is 400, 400 of next is this one. You are assigning head. What is the value is there? 100. So you have created a link like this. So again it is following the circular principality. So you will close the else block here. Okay, you will close the create function. This is the way you can create a collection of nodes in the circular linked list. If you still have any doubts related to the circular linked list, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next video, I will discuss how to insert the nodes in the circular linked list. I will discuss 3 scenarios. One is insert at beginning, insert at end, and insert at any particular position. So I request everyone to watch the next video related to insertion in the linked list. Thank you for watching the complete video. Have a nice day.